Okay, let's go over the stuff we talked about in class the last 2 days. So all right, start sharing the screen. So what I said was we're going to move away from like the SOHCAHTOA thing, and what we're going to do is we're going to look at our angles on the coordinate plane. So what I'm going to do is I'm going to go ahead and I'm going to start kind of drawing things on the coordinate plane and labeling things on the coordinate plane. So what we're looking at now is, again, what I had mentioned on one of the first days was our initial side. Our initial side is always going to fall here on the x-axis. Now, what I wanted to tell you was we started out with just on the right side of the x-axis. Well, I'm going to tell you it could be on the left side of the x-axis too. So the initial side is always going to be the x-axis. We're always going to put this angle, and it's called theta, and the way you do spell it is T-H-E-T-A, theta. That's always going to kind of have its butt up against the origin, so 0, 0 here, and one of the sides of the angle is going to be that initial side. So now what's going to happen is we are going to move that where we're going to have our terminal side, and our terminal side is going to be determined by a point you're given. So in this case, I'm going to give you the point x comma y. So this point is in the quadrant 1. X is going to be a positive number and y is going to be a positive number in this case. So what I want to do is, now that I have this angle here with the terminal side and an initial side, what I can actually do is if I draw myself a vertical line that comes straight on down here, what I am now doing is I'm creating a right triangle. And the way you need to work on this right triangle is, now I have all those pieces. I have a hypotenuse here. I have two legs here. Really, I have an opposite side and I have an adjacent side, because if you think about it again, what we talked about, the side that was across from the angle, so this theta is always going to be called my opposite side. The side that's next to it that makes it up is called my adjacent side. And then this side here that's across from the right angle is always called the hypotenuse. But what I wanted to tell you was we're going to stop calling it that. We're actually going to give it a different name. If you think about it, the length of this side right here, this adjacent side, is how far I go on the x-axis. So what I'm saying is I'm going to call adjacent x from now on. So instead of adjacent, I'm going to call it x. And instead of opposite, if you look at this opposite, the opposite tells me how much I went up on the y-axis. So I'm going to call the opposite y. And what I'm going to do is I'm actually going to give the hypotenuse a new name. That new name is going to be r. And the reason it's going to be r is because it's a radius of a circle. We're going to find out that this side, this length is going to be the radius of a circle. If we actually took a circle and kind of connected it all the way around, kept the radius the same. So we're going to call the hypotenuse r, the opposite y, and the adjacent x. You're given this point, so you're given these two numbers. Well, I can figure out this number because of Pythagorean theorem. Pythagorean theorem says a squared plus b squared equals c squared. Well, in this case, a and b are x and y, so this becomes x squared plus y squared. And your hypotenuse is r, so it's going to be r squared. So in order to figure out r, we take the square root of both sides. And we'll find out that r equals the square root of x squared plus y squared. So that's how I can actually figure that out. So if I'm given a point, I can figure that stuff out. And what it allows me to do then is it allows me to redefine what we did before, because before we did SOHCAHTOA. SOHCAHTOA. And what we did before was opposite over hypotenuse, but instead of opposite and hypotenuse, I'm going to use y and r. Cosine was adjacent over hypotenuse, but instead of adjacent and hypotenuse, I'm going to use x and r. Tangent was opposite over adjacent. I'm going to use y over x. And what I'm going to say is all of these, remember, these are all my inverse or my reciprocals. So cosecant is equal to 1 over sine. Secant is equal to 1 over cosine. And tangent is cotangent is equal to 1 over tangent. So basically, take the reciprocals, r over x, r over y, r over x, x over y. So that's kind of the format we're going to use. So I'm going to go ahead and pause on this one and just say this is kind of the background on what we're doing, and then I'm going to do a couple other videos that kind of talk about the types of problems.